children, this is the chapter magnetic effect of electric currents. Whenever electric current is passed through a wire, the wire may be straight, circular or any kind of shape. Through that wire, if electric current is passed, definitely the effects takes place. Among that effects, one of the effects is also magnetic effect. Before going into the magnetic effect of electric current, we must know about the magnetism, the pure magnetism. In the previous classes also, in the earlier classes, from class 6th, 7th, 8th, in these classes also, you heard about the magnets. Okay? And in that magnet, there are various shapes of magnets. Among all the magnets, one of the basic magnet, the easiest magnet with which we can study their properties completely is the bar magnet. This is bar magnet. The bar magnet, it is in the cuboidal shape, right? It is in the cuboidal shape. When we see from any one of the face, then this magnet will appear like a rectangle. So that every bar magnet has two poles, that is north and south pole. Always a bar magnet will have two poles, north and south. They are only the north and south, not east and west. It is because of the basic property of this magnet. Whenever this bar magnet is suspended by a thread, then that magnet will align itself along a particular direction, that is north and south of Earth's axis. That's why we call the two poles are north and south. So always the magnet has two poles. The single pole is not possible. So that is one of the basic property. Magnet always exists in dipoles, right? This is one of them. And then when it is suspended by a thread, it always orients in a particular direction. Then coming to the next property. So the strength of these two poles, north and south poles, are always equal. Means if we put the iron piece nearer to this north pole at some distance from it, then if you put the same iron piece nearer to the south pole, so this north pole attracts the iron piece, south pole also attracts the iron piece. While attracting, they exert force on the iron piece. When that north pole exert force on the iron piece, south pole exert force on the iron piece, the force is equal. The force is equal. That's why we say the strength of north pole and the south pole are always equal. And then the strength is maximum at these 2 points. Strength of north pole is maximum at this point. Strength of south pole is maximum at this point. As we move into the magnet, as we move inside the magnet, the strength continuously decreases. So that means at the center, the strength of magnet is minimum. It is least. This is the one of the property of bar magnet, and this can also be verified by a simple activity. That simple activity is just take a cardboard. We can take a cardboard. On the cardboard, some iron filings are sprinkled. Iron filings are sprinkled and a bar magnet is placed. Suppose this is a cardboard. This is a cardboard. On this cardboard, we sprinkle some iron filings. Small pieces of iron are sprinkled on it. When we put the bar magnet on this cardboard, what happens? All the iron filings attracted towards the magnet And in that pattern, after attracting all iron pieces towards the magnet, we can observe a definite pattern. The definite pattern is that the iron filings attracted maximum at the poles. Maximum at the poles. So like this, you can observe. At the poles, maximum number of iron filings are attracted, and at the middle of this magnet, you can find least number of iron filings placed. So it also indicates the strength of north and south pole is maximum, right? So this is a property of the magnet, and then we can go to one more property also. Means that we have various different magnets, different bar magnets. If we take two bar magnets and their poles are bring closer, if we bring two similar poles close to each other, that means the basic property is similar poles repel each other and dissimilar poles attract each other. That is north and north repel, north and south attract each other. This is also one of the basic property of the bar magnet. So we have some number of basic properties of this bar magnet. Okay, and then if we put any bar magnet, then this bar magnet is able to develop a magnetic field around it. Now what is that magnetic field is? This bar magnet develops a space. It develops a space within that space, if anything is placed, if any iron piece is placed, that iron piece will be influenced by this bar magnet. That space within which any iron piece, small piece of materials are influenced is known as the magnetic field. So this is the magnetic field around this bar magnet, right? This bar magnet, if we take in 3D, it will spherical in shape. Okay. So in this, since this is the bar magnet, this is the magnetic field of this bar magnet, let us take this north and south. In this magnetic field, if you put the iron piece at various places, suppose we are putting the iron piece nearer to this, and the same iron piece is gradually moved away from this north pole, then what happens? The force exerted by this north pole on this iron piece continuously decreases. So after reaching a particular point, that is at this boundary, on taking this iron piece to this boundary point, we observe that this iron piece is not experiencing any force. That means its influence becomes zero. So like this, on the boundary line of this magnetic field, we have the magnetic field 0. So for this we call this point, the boundary points on this circle, we call it is the infinity for this magnet. So within that space, before that boundary point, these iron pieces will be affected by the bar magnets. So now, if we find the magnetic field at this particular point, that is different than the magnetic field at any other point. So the strength of magnetic field is different at every point inside the magnetic field. How can we calculate that strength of magnetic field? For that, the magnetic field, that is the space, has to be divided into number of lines that we call the magnetic lines of force. That magnetic lines of force, or we can call them magnetic field lines. Right? So now what are these magnetic field lines? How can we draw these magnetic field lines? And what are the properties of these magnetic field lines? That has to be discussed. Right. Now let us start to draw a magnetic field line around this bar magnet. For this, to draw the magnetic field line, what is required? A compass needle is required. A magnetic compass needle. In the earlier classes also, you people have seen this compass needle.